This is the EcoArk, planned to be one of the greenest buildings in Asia and possibly the world. It aims to be a glowing example of how to turn a problem into a solution. But it's going to be a 2-year nightmare for the man who's designed it.
I think it'll work, but our solution has some problem to it.
And a very steep learning curve for the man who's paying for it.
I don't know what I got myself into.
They face a long list of challenges from both nature and their colleagues. And even they don't know if they're going to pull it off.
No one actually believes the project will work.
They're entering unknown territory, trying to accomplish the impossible, turning Taiwan's trash into treasure. The EcoArk has to be the spectacular showpiece of the Taipei International Flora Expo. A horticultural extravaganza on an Olympic scale. On paper, it's going to be a 9-story high exhibition hall covering an area of almost 7 basketball courts. It's planned as the world's greenest plastic pavilion, to be built largely out of 1.5 million recycled drink bottles. The designer's choice of such a revolutionary new building material tops the list of challenges they have to overcome. The safety of 6 million visitors expected at the flower show will depend on recycled rubbish. Will an experimental plastic building 28 meters high be able to withstand everything that nature can throw at it, including earthquakes and typhoons? Will it melt or erupt into an inferno if there's a fire? The upcoming expo is all about environmental awareness, so the EcoArk has to be green and sustainable. This means using low-carbon building techniques and maintaining a zero-carbon footprint when the EcoArk is running. The lighting system has to power itself. The exhibition space has to be cooled without using air conditioning. And at the end of the expo, this pavilion made of recycled materials has to be broken down to be reassembled elsewhere. Then there's one more huge hurdle. Taiwan's senior officials have to be convinced that all these new and exciting ideas will work, or they'll bring the project to a halt. Designer Arthur Huang has to solve all these problems with very limited time and money.
Creativity is always very intense when you have a huge constraint in terms of budgets and also in terms of time. And that forces all the engineers being pushed out on the one goal. That forces us to make decisions very quickly, and that, I think, it's a very powerful tool for designers and innovators.
The tobacco leaf-shaped island of Taiwan lies in the Pacific Ocean, 160 kilometers off the southeast coast of mainland China. It's a third larger than the size of the state of Maryland. But because so much of Taiwan is mountainous, its 23 million people squeeze into less than a third of the land. Taipei sits at the northern tip, where 2.6 million Taiwanese jostle for space in a modern, productive city. Over the last 60 years, Taiwan has made a swift transition from agriculture to industry. It's now a world leader in manufactured goods. It's the largest producer of LCD panels. Taiwanese companies building 90% of the world's laptop computers. Today's Taipei is a vibrant mix of technological innovation and traditional Taiwanese culture. This healthy tension between the new ideas of creative youth and the wisdom of their elders has resulted in some spectacular successes. The Taipei 101 building, until recently, was the world's tallest. It's a symbol of Taiwan's economic and social stability, but growth always comes at a price. The side effects of rapid industrialization and consumerism accumulate at a frightening rate. The citizens of Taiwan try to cope with the plastic trash they generate. 90,000 tons of recyclable plastic bottles are collected each year. That would fill 3 Taipei 101 buildings, or encircle Taiwan more than 1,000 times. Plastic was part of Taiwan's prosperity, but now it's a growing problem. The figures have the island's leaders worried, and like Taipei's mayor, they're looking for solutions.
The plastic bags and plastic bottles, we were the plastic kingdom in the past. So right now we begin to think about how to make environmental protection and economic growth hand in hand.
Enter architect and engineer Arthur Huang, a firm believer in true sustainability. He and his team are under pressure to make the EcoArk green to build and green to run. But pressure sometimes sparks genius. They have an idea that could kill 2 birds with 1 stone. Could they tackle Taiwan's trash by turning it into a tribute to green architecture? Arthur didn't need to look far for inspiration.
What we did is we literally just look into our trash can, and that's how we started. Our engineering team loves drinking bottled teas, and this is such a culture in Taiwan. So we thought, okay, maybe we can take this material and turn that into something useful.
Most buildings in Taipei are made of concrete, steel, and glass. Materials Taiwan's senior engineers have worked with all their lives. The young designer's big idea for a new construction material couldn't be more radical. They want to build a show-stopping pavilion out of recycled plastic bottles. Just as a biblical ark saved animals from a flood, Arthur's EcoArk might save the world from drowning in a sea of plastic. It's an answer to a politician's prayers.
With 100% of plastic bottles, EcoArk sets a milestone in green building.
Even with the support of the mayor, this is a gamble for Taiwan. The EcoArk will be on show to the world at the Taipei International Flora Expo. Arthur may have studied at Harvard and Cornell, but his plan to turn plastic waste into a green building is going to be hard to sell. It sounds like alchemy, but the idea has a solid foundation in science. Plastic bottles are made from a thermoplastic resin called polyethylene terephthalate, or PET. This is easily molded into a bottle shape, but can it be transformed into a building? One of the world's largest producers of PET products is Taiwan's Far Eastern Group. Company chairman Douglas Hsu is concerned about the effects plastic are having on the environment. He's keen to support a project that puts his company's waste product to good use.
We want to be in the green revolution, so we looked through many ideas, and this one came up with this nice architect, Arthur. Why don't we use PET bottles? I said, that's wonderful.
Arthur's plastic pavilion now has an enthusiastic backer.
To make a statement, to help with the Taipei Floor Expo, we were given an interesting assignment to do one pavilion.
With funding from Douglas Hsu, Arthur can now start making his dream a reality. But can he pull it off? The stakes are high. The pavilion has to encompass all the right concepts for the horticultural exhibition. It has to be beautiful, it has to be strong, and it has to be sustainable. The idea is hard to accept. Making it happen is going to be much, much harder than anyone realizes. Designer Arthur Huan is gambling his reputation on constructing a showpiece EcoArk out of recycled plastic bottles. They'll cover a standard steel frame that will give the building strength to resist earthquakes. Inside the pavilion, Arthur plans a full-length walkway, a movable stage for fashion shows, an art installation, and a huge exhibition hall. It'll be the star attraction of the International Flora Expo, if Arthur can get it built. Using recycled plastic as a construction material is a wild idea. The problem is that it's completely unproven. One of Arthur's greatest challenges is getting senior experts on his side. They have to sign off his ideas, or he's going nowhere. At just 31, he leads a team of 3 designers whose average age is only 29. The EcoArk is going to be a battle between innovative young guns who want to break new ground and established and conservative professionals who fear the worst.
They're pushing us, giving us all these tough questions and trying to say that's not possible, this is not possible.
The future of this revolutionary green building depends not just on solving all the problems, but on who wins the tussle between experience and youth. Construction chief Lin Ko is one of many doubters.
Personally, I thought it must be a joke. I remember that I joked to Arthur that you got to be kidding me when I first heard about the idea. The concept sounds very nice and fancy, but if it is carried out in reality, it would be a very long process.
In early meetings, Arthur has to do some fast talking. People like construction engineer Chang Fongchen will take a lot of convincing.
I did think that it is a crazy idea, considering that I've worked in the construction industry in the conventional way for many years. But I understand that young people always enjoyed the challenge of carrying out crazy ideas.
Experienced old hands always look twice at the ideas of ambitious youngsters, and some of those ideas do seem pretty crazy. Can they really build a 9-story wall out of bottles? Even team architect Jarvis Liu doesn't know yet.
We didn't know where to start, and we collected various sizes and shapes of PET bottles. We wanted to know whether or not we could construct buildings with them.
Ordinary plastic drink bottles can't be used as they are. They're too soft and have no real structure. They're too round to lock into each other and can't support much weight.
If it's just a wall of PET bottles, it falls apart because there's so many gaps in between. So we had to find a way to make that stack efficiently and interlock efficiently without letting air and water coming through.
Arthur's team has to go back to the drawing board. A solution has to be found, and quickly. No one knows how much time experimenting with a new building material will take. And they're still not sure what that is going to be. After a number of attempts, they rework the traditional smooth bottle into a more practical shape. They take inspiration from nature. A beehive's honeycomb structure is one of the world's lightest and strongest designs. So the team uses it as the template for their basic building block. the idea of the polybrick is born. Like some ancient Chinese architecture, which used no glue or nails, the low-tech polybricks should click together mechanically, without the need for fastenings. Taiwan recycles 4.5 billion bottles every year, providing Arthur with all the raw materials he needs to make polybricks, which should interlock to make up wall panels. Not even Arthur actually knows if it's going to work.
We're literally sweating everywhere when things doesn't work out. What's that term called? Fire in the pants? Because I promised the client that we're going to deliver a half-scale prototype by a certain time. However, we couldn't get there.
With so much uncertainty, the young designers are getting flack from experienced members of the team. The concept of a public building made of plastic is hard to sell. The juniors have to satisfy the concerns of the seniors before they can move on.
They're really tough. These meetings are really a pain for a young designer like us because we're basically dialoguing and challenging the cream of the crop engineer in Taiwan. And of course, we know if we want to have very, very good work and have some true innovation, we definitely need all that years of experience.
The young team reckons that producing polybrick prototypes will convince the skeptical senior engineers that their ideas have merit. This is Arthur's chance to show that what works in theory will work in practice. Straight away, there's a problem. The polybrick design is so different from ordinary bottles that there isn't a machine the right size to mass produce it. There isn't time to build a new machine from scratch. So the team hires a second-hand one used in the food industry. It's a makeshift solution at best, and it comes with challenges. The team has to make custom molds to blow the molten plastic into. Then they have to guess what temperatures and pressures are needed to blow the perfect polybrick.
You're piggybacking on existing solutions and you're turning a food industry production grade machine into a construction grade machine. We do have lots of conflict with the engineer while we're doing this. The guessing part, I think, is what scares all of us and everyone else.
Fortunately, some experts appreciate what Arthur is trying to do. Blow molding engineer Fu Xing Liu rises to the challenge.
We found that the 130-gram bottle has insufficient side compressive strength. Therefore, we increased the thickness of the bottle to conduct further testing. Personally, I love challenges, especially those ones that couldn't be conquered by others. The greater the challenge, the better.
It's a nail-biting time. On the computer screen and on the table, everyone thinks the polybrick should be strong enough, waterproof enough, and able to handle the harsh environment. And despite resistance from the conservative camp, Arthur's team is winning converts.
Our senior engineers, they thought we were kind of crazy. So there's a huge conflict because normally a lot of things that we're trying to do, in their book, it would be no way. So at first, there's a huge amount of resistance. But at the end, when we start coming out with a series of demos and prototypes, everyone got pretty excited.
Finally, the seniors approve the design. The team can start molding the 480,000 polybricks they'll need for the EcoArk. Now the manufacturing process raises problems. sourcing the right bottles for the raw materials isn't simple. Recycling begins with collecting used PET bottles and baling them up for transportation. They are all shapes and sizes, colors and weights, and most have labels that have to be removed. Plant manager Jin Honghuan knows there's no such thing as a standard waste plastic bottle, and that means problems with quality control.
The building is designed to use 100% recycled material, which has been a big challenge for us. The recycled PET bottles were collected nationwide, therefore the quality of the collected bottles varies quite a lot. Making PET bottle bricks out of recycled bottles with different quality standards takes much longer time than using simply unified PET material during the testing period.
The bottles have to be sorted and the labels washed off. After drying, the plastic is crushed and threshed into small flakes. Some of the flakes are then melted down into PET pellets. Pellets and flakes are fed into the injection machine. The heated raw material is injected into a mold and allowed to cool. The resulting plastic sausage is called a parison, and this is what is destined to become a polybrick. The neck of the parison sausage is hollow, forming a canal through which hot air will be forced to create the polybrick. The parison is reheated and dropped into the polybrick mold. Air is blown into the neck of the parison, and it blows up like a balloon into the shape of a polybrick. At least that's the theory. The temperature is critical. Too cold and the plastic doesn't blow into the corners of the mold. Too hot and the sides are too thin and turn into a warm plastic mess. Only the perseverance of experts like production supervisor Hui Zhongyi is keeping the architect's dreams alive.
At the beginning, the blow result was not optimal, since we did not know how to set the perimeters. We kept trying and trying.
In the case of the polybrick, the tried and true method of blow molding is turning into a steep learning curve for everyone. Each new problem eats up precious construction time.
The problems are from productions because production is a whole different set of engineering that needs to be done. It's like taking an abstract idea on paper, in math, in formulas, and you're taking all that into an actual production. When you go to actual production, the machine has limitations, the material has limitations.
Eventually, they discover the magic numbers for temperature and pressure to create the perfect polybrick.
After numerous trials and errors, we finally made such beautiful bottles.
Faith, determination, and dogged persistence pay off in the end. At last, the collaborators have a polybrick they can work with. Only now can they commit to full-on mass production. The next step of building the polybricks into panels just has to work. With the opening of the International Flora Expo just 10 months away, the team has no choice but to forge ahead. If they get it wrong, there's no plan B to fall back on, and no time to build anything else. The EcoArk designers are gambling all their work to date on manufacturing 480,000 plastic bricks that might or might not hold up under pressure. The polybricks click together, imitating the honeycomb structure found in beehives, and accepted as a very strong construction technique. "128 polybricks make up a 3.2 square meter exterior panel, supported on one side by a wire mesh frame. The panels, each weighing only 18 kilograms, connect to each other like a wall of giant Lego bricks. It looks solid on the computer screen. But can a real-life experimental, lightweight plastic construction material withstand the full force of nature? Can it take a typhoon intensity hammering? It's not just reputations on the line here. It's the lives of the 6 million visitors to the expo. Taiwan is in Typhoon Alley. Each year the small island is battered by 3 or 4 storm-force typhoons. Experienced construction engineers like Lin Ko want to know how a building made of plastic bottles is going to stand up to the kind of weather that Taipei sees all too often.
Considering that the building is a public exhibition place and so many people would come to visit it, we shouldn't take any risk. We also insisted to conduct wind-rain tests on the external wall because of typhoon. The negative wind pressure could reach 1.5 times of the positive wind pressure when typhoon is coming. If the external wall is not solid enough, it might be blown away, which would be a disaster.
The senior engineers challenge the strength of the panels. A challenge that young team architect Stephen Lin understands.
Because they are very worried about the safety, and as you know, here in Taiwan, we have a lot of typhoons and earthquakes. They have their different thinkings about what we should do and what it should look like.
The panels will have to meet stringent professional standards, but the team tries a rough and ready test of their own.
At the very first time we get the poly brick, we make it into a panel and we put it like a bridge and we jump on it.
At the first hurdle, the panels fail. The polybricks that fit beautifully in theory don't fit in practice. The team finds it hard to build each panel exactly the same as the last. The smallest error in the manufacture of each bottle can be catastrophic when it is multiplied by thousands of bottles, which means the panels won't fit the space designed for them. This could be disastrous for the ambitious young architects, who still have their elders scrutinizing everything they do. Construction engineer Lin Ko has predicted problems with this job from the start.
It is quite a difficult task to join walls together, considering that the size of the whole building is quite massive. To ensure walls to be jointed seamlessly, each bottle needs to be jointed to the other perfectly.
Arthur has everything riding on this project. Failure is not an option. But in its first major test, the panels for his plastic wall fail. Big time.
When you put it in this huge wall, like 10 meters by 10 meters, the accumulated deviations become so high that the walls, part of a wall dramatically fail. It's like, imagine the polybrick pops out like a shooting cannon after all that pressure is being put into it. This is quite scary because you can hear these almost like gunshot noises.
Panels that work in the perfect world of computer design are failing in the real world. Tests show the 9-story wall will collapse. For the moment, the EcoArk is sunk. There's no abandoning ship. Arthur fronts up to failure.
What the hell are we doing? The past 6 months of investments and all that energy go into it, oh my God, how am I going to tell the chairman? How am I going to tell VP Guo? Obviously, I overpromised a little bit.
It's back to the drawing board. In Arthur's world, this isn't failure. It's just a temporary setback. There has to be a way to strengthen the polybrick panels. The solution they find is to support the panels on the outside with a tough polycarbonate sheet. This complements the wire mesh frame on the inside. The polybricks are sandwiched in a kind of straitjacket between immovable surfaces. The laser-cut sheets also solve the problem of tiny errors accumulating. Everything is now locked into precisely measured panels. Some polybricks fit through the internal mesh, and some fit through the outside sheet. This forces the assembly team to be extra careful. Get just one polybrick the wrong way round, and the pattern is disrupted, and you have to start over. But the panel design is solved. Computer modeling shows the panels have a design strength of 400 kilograms per square meter, the weight of a small horse. The juniors repeat their unofficial demonstration for the senior engineers. They jump into action, and this time the panels hold. The seniors accept the panels are ready for professional testing, but they still have questions. The polybrick neck and cap are screwed through the polycarbonate sheet to hold everything in place, creating a high-load shear point in the design. Can it take the strain of typhoon-strength winds? Finding an in-house test to imitate nature's fury takes a little ingenuity.
So we have a very funky test that we did. We actually have a hooking device that hook up the bottleneck and the actual rivets or the cap. When the wind is hitting the panel is slightly turning and is waving, so it has this forces going in the S shape. So we basically hung a swing on top of this cap to mimic that S-shaped forces.
For a brief while, the future of the EcoArk hangs by a neck. But the panel survives the swing test. Now, how will it perform in a fire? Plastic and heat don't mix. Visions of a fire in a plastic building full of visitors have to be considered. Arthur's team has to convince Taipei's fire chief that the EcoArk will neither burn nor melt in a fire.
We took 4 meetings with the fire chief. So when he has some doubts, we actually try to alleviate some of his concerns.
Arthur's solution is to laminate another layer onto the panels, a tough, scratch-proof PVC polymer substrate that resists both flame and melting. This time, the testing is easy.
The panel has not caught on fire or melt. So this is one of the tests we had to show the fire department chief that this new material could work for a public structure.
The test process is tough for all concerned, but everyone understands the reasoning behind it. The EcoArk has to resist wind, rain, fire, and earthquake. The design and engineering team has to prove every aspect of such a revolutionary building.
You have this not fitting properly, that not fitting properly, that is not really locking to another pieces, water pressure issues, strength issues, integrating with the wiring issues.
Eventually, after months of demanding independent tests, both locally and internationally, the EcoArk's construction system is given the all clear. The team's attitude and persistence are finally paying off and earning recognition from the building's benefactor. For Arthur, it's good to have such strong backing, but he has to prove he deserves it.
The big guy, Chairman Xu, is a very powerful man in Taiwan. And he gave us huge amount of support, like, let's do this, you know. And right away, everyone tried their best, at least, to try to reduce their doubts. But at the same time, we had to prove that at every stage that we meet the requirements.
After all the problems with the polybricks and the panels, it's finally time to install them. The 9-story-high steel frame skeleton is finished, and the EcoArk is starting to take on an imposing shape in the real world. For Far Eastern Group's Douglas Hsu, it's time to see where the money's been going. If Mr. Xu doesn't like what he sees, there's no time left for a major rethink, and even small changes will eat up time the project doesn't have. The exhibition opens in a few months. For Arthur, it's a chance to show what has been done and answer penetrating questions about what remains to be done. There are still many unresolved issues for architect and owner to discuss.
我那个时候跟他讲，
我 basically 那个风哦，台风是那个方向，
你下面是空的嘛，
对，
你要顾虑到风一来，这个空气就掉出来了，所以我里面哗出来这个东西，这一栋是很会受注意，对，会受注意，你再差一点，你这个新闻不得了。
There's a lot riding on this building. Not just the reputation of everyone working on the project, but those of Taipei and Taiwan. Tomorrow, the panels will start to be attached to the frame. For the lead architect and inventor of the polybrick, it's a huge moment.
心情当然又开心又紧张，所以今天星期天又跑来。对，当然就是又开心又紧张。联合报在刊登他们在访问我们的时候，很多建筑界的朋友就说：“哎，这个房子未免太梦幻了吧？”虽然我们做了很多测试，目前都是 OK 的，但是未来我只是当然还是有点紧张啊，这么。
Using an experimental building material for such a prestigious project is a huge risk. So Arthur's team keeps the construction simple. The EcoArk has a complex curved shape, but it's formed by a straightforward technique called a curtain wall system. A skin of polybrick panels is screwed and welded to a supportive structural steel frame. 1.5 million waste PET bottles are recycled to make the pavilion walls. Arthur is not the only one with mixed feelings of elation and terror. The whole of Taipei is watching. The EcoArk starts to come to life as the pre-made polybrick panels clad the steel skeleton. Each square metre weighs just over 70 kilograms, including the steel. That's about half the weight of a conventional building. And that's not all. Arthur's team has also met an important green challenge of sustainability. The building itself is recyclable.
I can carry the whole building literally per square meter, one piece and one piece off at the same time. The internal beam and columns fasten, so it's meant to be disassembled. It's chopped into sizes that's perfectly fit for container shipping.
At the end of the flower show, the EcoArk will be dismantled and rebuilt elsewhere. That pleases backer Douglas Xu.
This is not wasted. I'm hoping to recycle this whole thing, to take it all down, and then built it at certain other places in the world so that people can understand, hey, this is really renewable.
The junior designers are gradually gaining the approval of their elders. The EcoArk has even won over construction engineer Lin Cole.
At the very beginning, I just felt a bunch of crazy people were trying to do something unachievable. Look at what we have finished. Now I think those crazy people are a group of geniuses.
After all the heartache, the polybrick curtain wall is completed in just 10 10 weeks. Its cost only $250 per square meter, about half the cost of a conventional building of glass and concrete and steel. But there are many more problems to be solved. The inside of the building has to match the outside for sustainability, which means the green design team faces a whole new set of challenges. With the EcoArk's cladding of recycled plastic bottles secure, the designers turn to the interior of the building. During Taipei's International Flower Show, it will be an exhibition hall and a venue for fashion shows. With 6 million visitors expected over the next 6 months, the architects face a number of new challenges to ensure it is a truly sustainable building. Their first priority is air conditioning. They have to keep the crowds cool without costly electricity. Air conditioning the whole pavilion isn't an option because of its very high energy demand and its associated carbon footprint, which Arthur has to reduce.
40% of the carbon footprint is caused by making buildings.
And one of the biggest percentage of that operation of that building is actually air conditioning, cooling and heating.
The polybrick cladding already provides part of the solution. The hollow plastic bricks have air trapped inside them, and this gives the EcoArk a thermal advantage. This insulation helps keep the heat out and the cool in. Now Arthur's team plans to replace electricity with a force of nature. They're going to harness the wind.
Basically, you have to have a very smart facing building, facing toward the wind, against the wind. So we had to utilize our environment very as efficiently as possible.
The EcoArk faces northeast, the direction of the prevailing wind, in order to take advantage of a gap between the Grand Hotel and a corner of the Jilong River. As the wind accelerates through this gap, it is funneled under the uplifted bow of the EcoArk. The air then passes through a spectacular mist spray system, involving a water feature 26 meters high, and it cools the inside of the EcoArk.
And we lift the northeast corner above the tree line to catch that draft. Basically, from that draft, we divert that positive pressure of the wind. We slowly lift up the the skirt of a building or the intake of a building to get that cool draft into the building.
On wind-free days, the sloping roof forms a natural chimney, drawing hot air out of the building. Some green buildings around the world pay only lip service to sustainability, but the Taiwanese hope that their genuinely green projects will set a new trend. The designers of the EcoArk hope to make people think again about how buildings should be built.
We've been overproducing for quite a long time. The whole economy is based actually on making carbon or using existing carbon that's actually in our earth, and we're taking it out, make that into products, make that into cars, make that into houses or buildings.
One of the greatest green challenges is to effectively use no power at all. The EcoArk's lighting system does just that. The roof is angled towards the sun and coated with a thin film of photovoltaic panels. During daylight hours, the panels generate energy and feed it into the local power network. At night, 40,000 LEDs embedded in individual polybricks draw on that power to light up the spectacular EcoArk. Now, there's only one final test to come, the opening night of Taipei's International Flora Expo. For Arthur Huang and Douglas Hsu, it's a chance to display their green creation to the world. The dazzling EcoArk pavilion commands international attention. It's achieved its goals on all fronts. It's met the demand to be eco-friendly. It's a showcase for groundbreaking sustainable design and a worthy example of recycling at its best.
让全世界一起看到美丽的力量。
What we have done adds a statement, adds a objective, adds a goal to tell everyone that some of the materials are recyclable, reusable, and to make something out of junk.
It's a triumph for teamwork. The young guns of Taiwan, led by Arthur Huang and mentored by their elders, have achieved the seemingly impossible and turned trash into treasure.
So this is kind of our solution. Hopefully there are more people caught on and doing the same thing that we're doing, and then hopefully there's a collection of us that we create a whole different low-carbon economy together.
The EcoArk can't save the planet on its own, but its designers hope it can demonstrate to the world that there really are ways to build for a better future.